So today we are talking about the unit circle. And before we jump on our note sheet, I do want to kind of show you on this more interactive unit circle what we're talking about here. So the big portion on my page shows a circle. There is a line going straight up from the center to the outside of our circle. And with that line, if we trace straight down with this blue line, we get a triangle, a nice right angle triangle. Now, we kind of discovered from our Ferris wheel activity that blue line, the height, matches perfectly with our sine function. And that is what we're going to kind of label that blue line as when we get to our notes. And that co-height here, this green line, corresponds with our cosine function. And if I move this blue slider around and I change the angle that that black line is rotated around our triangle with, you'll see that the green and blue lines change how long they are, right? The green line's really long here, the blue line is short. Right here, the green line is really short, the blue line is long. So depending on where that black angle is, how far we rotate around our circle, our cosine and sine values change. So let's kind of bring this into what our notes are. Let me zoom in a little bit just so we have a better view of what I'm drawing here. We're going to kind of mimic what we saw in that animation. So we are going to create a straight line coming out of our circle, and it's going to intersect maybe at about this 45-degree point here. And we're going to write a couple things around this line. The first thing we're going to do is going to say, all right, we've rotated off our 0-degree line an angle of theta. And that theta is a lot like x. It represents a future number or something, or an unknown number of something. In this case, we're talking about degrees. So theta degrees of rotation. The other thing is that this unit circle here that we're dealing with, in order for us to define sine and cosine correctly, we're going to say that this has a radius of length 1. So our circle all the way around has a radius of 1. Now, what we saw as well is if I traced a straight line down from my circle and hit that 0-degree line at a right angle, that we could call that height sine of theta. And it probably helps to make some distance markers here just to show that that sine of theta is talking about the height of our triangle there. Now, just like sine of theta is talking about our height, cosine is going to be talking about our width. So if I write in cosine of theta, okay, I have the width of my triangle. And I'm going to go ahead and make a kind of thicker blue line kind of showing the width of that triangle there. Let me zoom out a bit so we can see our full circle again. So as we kind of rotated around in our animation, if I go back here, as we rotated around, our cosine and sine values are going to change their positive and negative sign a little bit. If we're staying in this upper right quadrant, quadrant 1, our cosine values are going to be positive. So I'm just going to write in a plus sign there. And our sine values are going to be positive as well, right? Everything to the right and everything above, those are positive values. Then if we rotate into our quadrant 2, our upper left quadrant, our cosine values become negative there. Those become negative. Our sine values stay positive because they're still above that x-axis. As we continue rotating down, both values are going to become negative. Again, this is just like we saw with our Ferris wheel. And finally, in quadrant 4, if we're on the lower right, my cosine values are positive because we're on the right side of our center, and our sine values are negative. So the final thing we want to add to our notes here is just kind of filling out this info in the bottom left here. So for the unit circle, and remember that there's a radius of 1 here. I'm going to zoom in just so I can write a little cleaner. for our unit circle with a radius of 1, we have a cosine value that is equal to what our x is, right? Whatever our x is along our graph, that's what cosine is going to be equal to. And we can also write that in as, hey, that's what our co-height is equal to. Okay, and so our sine value, which is our up and down, that's going to be what our y value is equal to on our unit circle. And again, we called that the height during our Ferris wheel activity. So using this information, I want us to go around and kind of detail out a couple of key values, key angle values of cosine and sine at different points around our unit circle. This is one of the first activities we're doing in class today. It'll probably take us about 10 minutes. But if you use this GeoGebra tool, and let's say go to that first angle we looked at, 30 degrees. I'm going to click that right into 30 degrees. We can see that my cosine value and sine value listed in the top left are 0.87 and 0.5. You can also see those displayed on our circle here, 0.87, comma 0.5. They're written just like x, comma y. Okay. So as we go around our circle, we're going to list these as x, comma y, or cosine, comma sine, because x is going to be kind of equivalent to cosine. Y is going to be equivalent to sine. So I'm going to go in, zoom in a little bit just so we can see it better on my screen. We said my x value, my cosine value was 0.87, and my sine value was 0.5. Then we can go to the next angle on our unit circle, which was 45, and make sure we're accurate here, and see that our cosine, comma sine values are 0.71 and 0.71. So go in here and mark that on our unit circles on the back of our sheet. And we can continue doing this until we have all 12 of those key angles filled out. And your final unit circle should look like this, where we have positive values in quadrant 1 for both cosine and sine, negative cosine, positive sine values in quadrant 2, both of them negative in quadrant 3, and then positive cosine, negative sine in quadrant 4. So the final thing I want to show you today is being able to find sine and cosine values now that you've built out this unit circle. So in example 1 here, we are being asked to find the cosine of 60 degrees. So let me just first mark this. I'm going to treat this as our gold problem here. So I'm going to underline this cosine of 60 degrees. And basically, if we were to trace out from our 60 degree line on our unit circle, okay, we have two values here that we could potentially pull. We have the 0.5 and the 0.87. Well, our cosine value corresponds to the first value listed. It corresponds to our x coordinate, which in this case is 0.5. So cosine of 60 is equal to 0.5. Okay. If you get the hang of this already, go ahead and try example 2 and example 3 here. I'll go ahead and do this as well. So I'll use our kind of salmon color for this next one here, sine of 120. I'm going to go to my unit circle. I'm going to kind of trace along that 120 line and see that that sine value is not negative 0.5. That's our cosine value. My sine value here is 0.87. And finally, our last problem, sine of 240 degrees. I'm going to go find that 240 line on my unit circle and pull my sine value, which is not the first one, it's the second one. In this case, it's negative 0.87. Make sure that negative sign is important when that comes up.